Yay! Hello again, friends! Welcome back to part 2 of Math Monday's exponents and logarithmic functions. In this second part, we are going to learn what a logarithm is, how to wield it, how to use it to solve problems, and then we'll use working through a simple problem to build up an understanding of the rules of logarithms. All right, here we go. Okay, so I'm going to start by erasing what we just did in part 1. Oh my gosh, I think my eraser got a little wet. Okay, so remember that an exponent looks like this, where these are constants and that's where our variable is in the exponent. And so when we have a logarithm, oftentimes we are talking about base 10. So our function looks like that. And so if we want to understand how this function changes over time, we can do the same thing we did last time with our first exponential function and draw a table of values. So if x is 0, f is 1, x is 1, f is 10, 2, 100, 3, 1,000, 4, 10,000, etc., etc. You get the picture. I'll do my little ... And so as x changes by one whole number, f of x changes by a factor of 10. And so in this case, you can see how quickly this function increases over values of x. Another way to write this, and a lot of times the reason why we want to do this is because we have an equation that we need to solve. So say, for example, I asked, what value of x makes this equation true? And you would be like, yo, I'm gonna just look at the table of values and pull out that row, because that's when f of x is 1,000, and be like, x has gotta be 3. And I'd be like, yay, I'm so happy that you used our previous work to answer the question. And that would be correct. But if we wanted to solve this by hand, if we hadn't done this work, or maybe if I asked you 10 to the x equals, I don't know, some huge number like 1 billion, and then I said, what is x? You would probably either go and look up a graph of this and pull out the point by hand, or you might sit and do the table up until you get to 1 billion. But let's be real, we're mathematicians. We want to be lazy. Let's make our lives easier and build on the work done by other folks so that we don't have to spend our time. Because there were mathematicians way back in the day, I don't know who exactly, but they spent years, probably, I'm going to assume hours, certainly, making really accurate plots of equations like this so that we can then take their work and build off of it. So we don't actually have to do this by hand. If you go to your handy dandy calculator, including the one on your smartphone, if you take your smartphone calculator and you flip it sideways, it'll expand a bunch of features and you will see the log function, I guess is what I'll call it. And so the way that this works, I'm going to erase this. So in this case, let's use our last example. So 10 to the x equals 1,000. So in this example, I'm going to pull out some handy colors. This is our base. So that is basically our base. So our base means it is the number with our variable raised to the power. This is our exponent. And let me grab another color. And this is our answer. Okay, so using that, let's learn how to do log notation. So log notation is most often shown with base 10, but you can do it for other numbers besides 10. If you're going to use the calculator on your phone, the standard base is going to be 10. But we can still do lots of other equations, and I'll show you why in a second. Okay, so then we have, typically what you'll see is a parenthesis, and then inside of the parenthesis we have our answer. Trying to get my colors straight, oh my gosh. So in this case we have 1,000, and then I'm gonna use white to close the parenthesis, and equals x. So in this case our base goes here as the subscript for log. The answer goes in parentheses, and our exponent goes on the right side of the equation. And so basically what we're saying is, if we have an exponent, or a number that has an exponent that is a base of 10, and the exponent, our base to the xth power gives us 1,000, then what is x? And by readjusting our equation this way, we can actually solve for x. As it is right now, it would be super hard. You actually would have to do it by hand. But like I said, there have been a lot of folks that have figured this stuff out already, so we'll just build off of their work and make our lives way easier. Okay, so this can be a little tricky to understand at first, like anything new in the world, right? I remember every time I learned a new French a new way of conjugating a verb in French, like past imperfect tense, it would take me a second to be like, wait, what am I conjugating and why? But you do practice problems, and you talk to people, and you read, and you write and write and write and write, and then you have someone check over your work. And you check over your own work, and then eventually you're like, no problem, I can do that. Math is the same thing. So let us do an example. Cool. Okay, so let's say we have 6 to the x equals 20. And then I'm like, yo, what's x? We gotta find x. What number gives us 20 if we have a base of 6? Where do we start? Oh my gosh. Okay, well, so first of all, we're going to do a classic math trick where we rewrite 6 and 20 using logarithmic notation. So we can rewrite 6 in this way, 10 to the log of 6. And you're like, wait, why does that work? How is this true? So let's back up a second. And remember, when I say log of 6, and if you do not see a subscript on the log, you assume that it's 10. This equals some number, right? So in this case, this is my answer, and this is my base. So in this case, I know that 10 to the x is going to give me 6. And if we actually solve that, you can follow along if you'd like. I'd highly encourage that. So if we ask, what is log 6? I'm going to get an answer. That x equals 0, actually let's call this a so that we're not confusing it with this x over here. A equals 0.7782. Usually I only keep 2 or 3 significant figures. The more you keep, the more accurate it is, but as long as you know what you're doing, that's more than sufficient. So then I can say, okay, well, let me just double check, and I should get 10 to the 0.7782 equals 6. And I'm going to put a question mark here for now. And so if I do 10 to the second answer, look at that. So there is the calculator work. Hopefully that's not too blurry for you. Boop. I also have a lot of chalk on there. Okay, but that's why you gotta do these practice problems with me, because then you can see for yourself. I think that is more powerful. So, yep, that works. So this is an acceptable way to write the number 6. It's kind of like saying, another way to write 6 would be to say, oh, I don't know, let's see, 6 to the 1. That's fine too. You could also say 6 plus 0. That's fine too. You could also say 6 over 1. Those are all equivalent. Classic math trick is you just take your equation and rewrite it in a way that allows you to simplify it. Doing the same thing here. We're just applying new rules. Yay. Okay, so then we're going to do the same thing on the right side of the equation. We'll say 20 equals 10 to the log 20. And you should do this process over to make sure you understand why this is true. And then what we can do is we take these two and use it to rewrite our equation. So we can say 10 log 6 as a replacement for x, and then that's going to be multiplied by x, equals 10 log 20. Okay, so now, because we know that we have some exponent tricks that we know, like a to the b times c equals ab times c, just like that. We can bring this 6 in and say 10 to the x times log 6 equals 10 to the log 20. And let me just double check. Yup, that's cool. Okay, so now we have the same base on both sides of our equation. And so we're like, hey, wait a second. For this equation to be true, this exponent must equal this exponent. What? Okay, now we're getting somewhere. So now we can just focus on the exponents and say that we know x times log 6, and again we have a little base 10 there, equals log base 10 of 20. And we're super close. All we have to do is divide log 20 by log 6 and we are good to go. Okay. So definitely do this with me. Grab your calculator and say log of 20 divided by log of 6. Huzzah! All right, we have our answer. X equals 1.672. Okay. And so if we wanted to double check our answer, which is always good to do, we would just plug this in for this equation. And I will do that now. 6 to the, whoopsies, 6 to the, that power is 20. There we go. Check it out. Hopefully you can see this one. Okay. All right. So there we go. Pretty rad, right? Logarithms are super handy. So I'll end by going over the 3 main rules of logarithms, one of which we basically just derived. So the first one is the product rule. So if you have a log with base b of a times c, you can separate these and add them and get the equivalent result. So you have log base b of a plus log base b of c, with a, b, and c are positive numbers, and b cannot be equal to 1 because 1 is a very unique number and it does some funny things with exponents. Okay, and then the second rule is the division rule. It's very similar to the product rule. You just swap the sign. So if you have a divided by c, then you have log base b of a minus log base b of c. And this same condition applies here. And the third one is the exponent rule, where you have log base b of a to the x, and we sort of found this one in the last one. And so in this case, you actually, whoops, a to the c. In this case, you pull it out front, and you have log base b of a. So for this one, c must be a real number, aka not a complex number. If you're like, what's a complex number? Check out my video on complex numbers. Hey. Let's see. And then a and b must be greater than 0, and b cannot equal 1, because 1 does some funky things. That's pretty much it. Cool, right? Logarithms are so fascinating. And fortunately, they have been studied extensively, so we just get to learn what other people have figured out. Huzzah! All right, Please let me know if you have any questions on exponents or logarithms. And of course, if there are math topics that you're super curious about, please let me know and we'll tackle it together. Yay! All right, I'll see you next week. Same time, same place. Bye!